Hey, welcome back to tutorial 6 of our Altium tutorial series. So in this one we're going to finally finish a PCB design and upload it to JLC and see how we order them. Again, this one's just me. And so last time we finished the routing, we fixed these 90-degree corners, we filled in all the dead copper with a ground connection, which poured across the entire thing. So where do we go from here? So the first thing you're going to do before you upload is something called the design rule check. So I've actually gone ahead and filled in some more rules from the JLC website, as I recommend you do, in our rule dialog box, like I mentioned. So now that that's done, I can actually do the design rule check, which I go to Tools, Design Rule Check, and here it is. So what is this? So this is going to go through and check everything you've done and give you a final report that is going to include like fatal errors, things that you cannot send the PCB out with, as well as some warnings and advisories for things that you should consider revising before you send out. So if I run this, it's actually going to generate a new document, and this is my Altium Designer DRC. So you can see I have 0 problems right now. I went ahead and actually checked this, but let's see what happens if you do have some problems. So let's create a problem for ourselves and see what happens. What's an interesting problem to have? Maybe I will have a clearance error somewhere. So let's shelve these polygons for a moment, and let's route a trace where it shouldn't be, for example. Or actually, even better, let's do an issue with the designator. So let's say for some reason that I wasn't careful about where I put this, and I put this designator too close to other things. So this is, these two things are too close together. When the manufacturer actually goes to print on top of the circuit board, they're not going to be able to recreate this gap. They don't have that kind of control over the silk screening process. Another one that you're going to see super often is something called the solder mask expansion rule. Basically, when they go to coat a circuit board with, the color that you see on top, either green or actually JLC has a couple different options, they're going to cure it, usually with UV light or something similar, and then that's going to harden on top of the board. And when it does that, it's going to change size a little bit. That's called the solder mask expansion. So you need to have some tolerance room for the solder mask to expand, and that's something that you actually specify in your rules. I have done it already for some parts. Let's find one where I did it the correct way. So right here you can see solder mask expansion rule. It's referring to the rules that I've set, and it's actually set as 0.2 millimeters, or no, sorry, 0.05 millimeters, I think, for JLC. The other option for a design like this, so this design, it uses big parts, they're all through hole. If there's a little bit of solder mask expansion or something, I probably don't care. So the other thing I can do is select these and manually just tell it not to worry, 0. That's not really a great practice, especially when you start using parts that are pretty small, and a slight shift in the size of the solder mask could matter a lot. But for this design, it's actually going to be fine. So let's just actually go with this right now. So you can see I have that error. If I were to run my design rule check, I say run. I need to re-pour polygons, of course. And now you can see I have some violations. So the first one is design contains shelved or modified but not re-poured polygons. The result DRC is not correct. So what it's basically saying is that I need to come into my tools, polygon pours, I need to restore them. Now you can see there's a bunch of issues because, well, technically I changed some things that shouldn't matter, but regardless, I need to re-pour. Okay, and so now let's try that again and see if we have fixed that problem. Of course we have. So you can see here there are 0 warnings, which means this board could be sent out and what came back would probably be a functioning circuit board. However, there are still rule violations in here. So if I go down, I can see there's 3 in total, and all 3 of them relate to silkscreen clearance. So if I click on that link, it brings me to an actual list of all of the violations. If I click on any one of these, it gets highlighted on the board. So there they are. just like we anticipated, there are some problems here. So this distance is too small, this distance is too small, counted it 3 times. So how can we fix it? Well, of course, we'll just put it back where it was, which was within tolerance to begin with. And I am having a little trouble selecting that. There we go. Let's put this here. And now there are no violations, although that doesn't look centered to me. So maybe I can center this a little better. Guess it's not too important, but I think that looks a little better. Okay, so now, finally, we want to keep adjusting our rules. We want to keep adjusting our actual routing and component placement, and we want to adjust, which things we waive. For example, sometimes it'll be particular, for example, like the expansion rule in a board like this. I just happen to know, and you might too, that a slight shift in the size of the solder mask won't affect, your board. So you can waive that violation, or you can send it even though it has that violation if you want to. We strongly recommend that you clear up all of your violations, because if you have problems later, there's a good chance that they came from you saying close enough too many times. But I think in this case it actually is close enough. If I hit 3, we can get our 3D view. You can see this board is big and simple and easy to solder and doesn't have any super high frequency signals or anything like that, so it should be pretty robust. So how do we send this to JLC? So let's go to our project tab. Here's that project right here. It's called, oh my bad, it's called Tutorial 4 because that's when I started this. I'm going to right click on it, add new to project, and this time I am going to say output job file. So let's give that a second. There we go, and we get this page. So this is an interesting page. What this entire document is going to do in this project is create different types of outputs. So that includes fabrication outputs, which we want. It also includes documentation outputs, bill of material type outputs, simulator outputs if you've done that. We haven't talked about that. But let's just start with fabrication. So if I click here, add new, Gerber files, and then I can use the tutorial 4 PCB doc. Probably shouldn't have named it tutorial 4, but that's all right. And then, as well as Gerber files, I need NC drill files. Okay, so if I right click on these, I can actually change some things about them. So let's take a look. If I go to configure, I can set the units. It doesn't matter what the units are as long as they're the same on both the Gerber and the drill files. So I'll leave those as they are. I can go to my layers and I can see which layers I include to send to the manufacturers. So what ones am I going to need? I am going to need my top overlay. I'm going to need my solder, the actual top layer, of course, the bottom layer, the bottom solder, the bottom overlay, which we actually didn't use, but you probably will. We are going to need mechanical 1, and that might be it for now. Yeah, let me just read through these real quick. And we'll see if this is right because we'll get some feedback later as we go. So let's hit OK. I don't think we need to change anything in the drill files as long as it's the same as the Gerber files. So we'll hit OK. And then what we're going to do is add a new output container. We're going to do a new folder structure, and we're going to name it Fabrication Outputs. Like that. And then while this is selected, if I click this and this, you're going to see that it actually puts these into here. And that's what we want. Let's also do some documentation outputs because you're going to want to do this. So you have a couple different options. You can do, let's do a, let's see here, schematic print. Yeah, you might want a schematic print. When you go to assemble your PCB, you can have a printout of your schematic next to you. So that could be helpful. I wanted a composite tutorial for it, and this is going to be, yeah, composite drawing is fine. Let's get rid of this. I can hit delete. If I right click on this, I can go to configure, and you can see I have some options for how it draws the schematic. The other thing I want to do is page setup, and I want to go to color. Okay, and I think the same thing here, page setup, I want color. Close. Okay, now let's regenerate this content, and we want to overwrite the old files. It's going to do that thing where it doesn't actually load. Very interesting. Oops, and I need to add that to the this container, my bad. Let's try that one more time. No, thank you. Okay. And now, I believe this is the newest version of this, right? Yeah. Cool, okay. Yes, this is what I wanted. So now I can have a picture of my PCB, which will be handy when I go to build it. I can actually like refer to this and like see, okay, here's where all the parts go. And then I have my full color schematic document. So those are great things to be able to have. And now what do I do with my Gerber and drill files? So what I'm going to do is, there's a couple different ways to do this. My favorite way is to select all of these. I can hit copy, and then I can go to my, whoops, where did it go? Tutorial 4. Outputs, there we go. I'll go to my Gerber file, and then I can hit right click, paste. That's great. Now if I right click on this, I'm going to use 7-zip. You can use whatever zip program you use, and I can say add to gerber.zip. And there it is. And I've zipped my drill files and my Gerber files together. I can rename this if I want to. Maybe I'll call it like fabrication files. Cool. And let's go to the JLC website. So here we are. Let's say I go to order now. And the easiest way to do this is to just grab this zip file. Let's minimize this. And let's just drop it right on here. Perfect. There we go. So JLC offers a Gerber viewer. Actually, a lot of different websites will offer a Gerber viewer. I need to sign in. So let me sign in real quick. And then I can access the Gerber viewer. And this is where I can make sure that everything is looking right. It's going to take a second to load. There we go. Okay, so I can zoom in. I can look at my board. I can make sure that the silk screen is going to look good on top. I can flip to the bottom view. Obviously, this bottom view is very simple. So obviously it's going to be fine. I can change the color. I happen to like the black ones. I think look really sleek. Of course, you can choose whatever. And it's great. Okay, so back here, how do I order a PCB? So it's going to auto-calculate dimensions when I upload. Obviously, this is a 2-layer board. And then the quantity. So you can have 5 PCBs for $2, and you can have 10 PCBs for $5. JLC is a really cheap manufacturer, so you can actually get a lot of boards. You can see that 300 only costs $50, which, all things considered is not that much money. But obviously for the project, we're going to recommend that you choose the 10 PCB option. 5 PCBs sounds like more than you need, especially if you're only trying to create one PCBA. But they go fast, especially if you make a couple mistakes. You make 2 or 3 mistakes. I just did that the other day. Actually, all of a sudden you only have 2 boards left. Now the pressure's really on. So, 10 PCBs for $5 is a pretty good deal. That's a good place to start. Different design? No, this is only one design. This is going to be a single PCB. That means they're going to actually cut the PCBs out and send them to you as packaged individual PCBs. That's what you want. The thickness you can leave as 1.6. Changing that number might affect the price of your PCB. Let's see. Looks like it actually... Oh, okay, so 0.4 PCBs are very expensive. 1.6 is the standard size. Let's see, I probably have one next to me. They're about this thick. Hopefully you could see in my picture. It's the normal, it's the default thickness. That will probably be fine for most projects. Then you can choose a color. You can see that green is the fastest turnaround. These other ones actually take a little longer, 2 more days to manufacture, up to you. And then you have surface finishes. So by default, you get the HASL with lead. That one's free. To have it lead free is just like, let's see, $1.10 more. So that's a good option. And then there's this thing called ENIG, which is a type of finish. Basically, they're going to electroplate it. It's going to turn all of the pads gold and make them very durable. It's a really nice thing to do when you have lots of soldering to do, or you need a PCB that's going to be very robust and the color looks nice. So this is a great treatment to get on your PCB, but you can see that it costs a lot of money. $16.70 is more than 3 times as much as 10 PCBs. So consider that. Think about if you have the budget for that. That is a premium option. But for most designs, I think probably this lead-free option will be okay too. Copper weight, 1 ounce. That's fine. Gold fingers. Probably no one has gold fingers. That would be, well, you can see the description right here. Gold fingers are the gold-plated columns along the connecting edges of PCBs. So unless your PCB is plugging into something else, you probably don't need that. Confirm production file. I'm going to say no on this. I think that means that they are going to, JLC PCB engineers will create the production file required to manufacture the PCB. You can check and confirm it before production. No, we don't need that. We were very careful when we designed the PCB. Flying probe test. You can decide what you want on this. I think we'll just have it be fully tested since they offer it for free anyways. Castellated holes. That is a special thing that you'll select when your PCB has, basically they drill holes and then they cut along them, and that gives you these little contacts that you can easily solder onto other PCBs. We don't have them. We're going to say no, and then remove order number. Yes, we're going to remove the order number. It is an extra $1.50, and I don't want an order number on my PCBs. So that's about it. The stencil. Yes, the stencil is kind of where they get you. What is a stencil? So a stencil is when you spread your solder paste onto a PCB. I think I have one next to me actually. So if you have surface mount components and you spread your solder paste across the PCB, you need the stencil to help you do that. And this is a little device. They cut it out of aluminum for you. I'm holding it up to the camera. And you can see it just has holes in it that are cut out that align with the pads on the PCB. So you spread your solder all on top of this. It only gets in the correct places. These are kind of expensive, and if you decide to get one, you need to make sure to change the dimensions or you're going to end up with a giant one. I've made that mistake before. You don't want an absolutely gigantic stencil. They're hard to work with. So I can customize a size if I need one and give them an X by Y measurement for that. But I'm not going to, because this design is a through-hole design, which means I'm not going to use a stencil. I'm not going to have SMD components or soldering to do. If you have small chips and small parts, this is a pretty great option, and I think I would actually strongly recommend it for anyone. If you're using a QFN package on your board, you're going to need this. So strongly consider whether or not you'll need a stencil. Feel free to consult with M5 staff and ask them if they think that's a good idea. If you have a board that's pretty big and it has one TQFP package on it, we can probably hand solder that, and you don't need to spend the money on a stencil. You can see that the stencil by itself costs more than all of the PCBs. So, and that's about it. And then we'll save to cart, and we'll, you'll purchase. You'll have someone purchase it on your behalf, I mean. And that's it. So there's only one more thing I want to talk about, and that is how to share your finished project with other M5 staff or teammates or your advisor or whoever, so that you can get feedback and talk about what you've done. So there's a really cool tool online. If I look up Altium 365 viewer, you can see what that tool is. So this is a way to upload and share your design. So let's take, for example, this design. How do I share this with someone? If I go to Project Packager, I get this little pop-up box. And these default settings are actually almost always going to be fine. So you can make sure they go in the right folder. Projects Tutorial 4. Yep, that looks good. Next, and finish. Okay, what did that do? That created a zip file right in the same directory as everything else. If I go to Tutorial 4, there it is right here. And what I can do with that is drag it onto Altium 365 viewer. And it's going to load for a moment. And then you're going to get a really nice interactive display of your schematic, your board in 2D, your board in 3D, as well as your bill of materials. And then you can even have a share link, which you can send to other people. So now you can see, here's the board. I can click on anything. I'll get information about the wires in it. Here's you can click on components, get information about those components, all kinds of things. You can get the URL for the datasheet, pretty much everything. If I click on PCB, give it a moment. There it is. It's already going. And I can show different layers. So let's say I only want to see the bottom layer for whatever reason. I can hide the top. Or even better, I can go to bottom layer and say only. Now I'm only looking at the bottom layer. Yeah, this is a great way to navigate your design and share it with people. If you click share, you actually get a link that you can copy and paste, email it, text it, send it in Discord to anyone else, and they can actually go on here. I can see it in 3D, and I can see the bill of materials. And what's great about this is also if you kind of come in here and click on a component, I can go through here and it'll actually find it for me in the 3D view, it'll find it in the PCB, it'll find it in the bill of materials. This is a great tool. I highly recommend you use this, especially when you're consulting with M5 staff about issues with your board. Sending them a link to your design is a great way to have them take a look. So I think that's all I have for this tutorial. Thank you for watching and following along, and let us know if you have any questions. Thanks.